Hey guys, this is day 3 now of leak coding until I am no longer trash at leak code. Today we're gonna do the first 3 problems: valid palindrome, two sum, and three sum. Um, let's just get into it. First one: given a string S, return true if it is a palindrome, otherwise return false. A palindrome is a string that reads the same forward and backward. It is also case insensitive and ignores all non-alphanumeric characters. Um, so the first example is a palindrome because it reads the same. Um, First thing we need to do is remove all spaces from our string. So to do that, we're going to replace the string in all cases where there is a space. So if we print S, we should see that there is no longer a space. Correct. Now it says we also want to ignore all non-alphanumeric characters. Okay, so instead of replacing the spaces with non-spaces and getting rid of all of the non-alphanumeric characters, I say we just loop through the string and we just basically check those conditions. So for character in string, we want to have 2 pointers. Left is going to be 0. Right is going to be the length of S minus 1. And then we're going to say, actually, let's do a while loop. So let's go while left is less than right, less than or equal to right. If S sub left dot is alnum is false, then I want to increment left. Left gets left plus 1. Else, elif S sub right is not alphanumeric, then I want to decrement right by 1. Else I want to check if S sub left is equal to S sub right. We should probably check if it's not equal to right, because then we can return false. And then after, we can say else. If they are equal, we will decrement and increment left and right. So left plus 1 and right gets right minus 1. And then we return true if we get here. So, okay. So I'm not sure if a space is alphanumeric or not, so we can just go s dot replace. So where are we getting the wrong? Oh, that's right. We need to also, it's case insensitive, so we have to make it lowercase. This problem is very fun. Took me way longer than I was hoping. That's why you read the problem though. Okay, let's get rid of these two. Let's submit. And perfect. Given an array of integers, numbers that is sorted in non-decreasing order, return the indices one index of 2 numbers such that they add up to a given target number, and the index 1 is less than index 2. Note that index 1 and index 2 cannot be equal, therefore you may not use the same element twice. There will always be exactly one valid solution. Your solution must use O of 1 additional space. Okay. So what's my first thought here? Similar to the other question, we can use a hash map, right? So we can store the number that we're looking for. And I don't see a problem with that since it's always going to be two numbers. So we can make a hash map. We can loop through our numbers. Oh, we want the index. So let's go for I in range length of numbers. Number sub I. If the count is in res, then we want to return res sub count and I. If it's not in count, then we want to simply go res sub count, res sub number sub I gets I. So basically what we're doing here is we're looping through the numbers, we're decrementing from our target, our current number. So for this example, we would take 3 minus 1 and see if there is a 2 in our res. There isn't, so then we would add 1 to our hash map with the index being I plus 1. And then we would go to 2, we would go 3 minus 2, 1. We would check if 1 is in our hash map. It is, so we'll return the index of 1 and the current index. Let's run it. Submit. Cool. Next one, given an integer array nums, return all the triplets where num sub I plus num sub j plus num sub k equals 0, and the indices are all distinct. The output should not contain any duplicate triplets. You may return the output and the triplets in any order. Okay, so we want to add up to 0. First thing that comes to mind is recursive function, like a subtree. So at a given index, we decide if we want to take or leave that index. And we'll do both conditions, and we'll check if we already have that in our output. And yeah, I think that would work. Now, the only problem here is that this would be the first time I'm coding this solution or watching Leetcode do it. So let's see. Okay, so here's our nums array, and here is our output. So our target is 0. And basically, we want to find 3 numbers that add up to 0 and cannot contain any duplicates, any duplicate indexes. So in this example, we have 2 -1s, but they're different indices. So in our example, -1, -1, 2 adds up to 0. And then -1, 0, 1 add up to 0. And that's the only combination in this nums array. So my thought is we do a decision tree. So for each index, we decide to take it or leave it. So for the first one is -1. And I guess this might be easier if I draw it. So the first one is -1. So we can decide to take a -1 or leave -1. We'll get to a point where we have 3 numbers, 0, 1. And at this point, we'll want to check if those three numbers equal 0. So in this case, they do, and we'll want to append it to a res hash map, and that will allow us to basically have a check before we add something to our res. We want to basically check if it's already existent in the hash map, and the array will be the tuple, or the array will be the key. I think this works. There could be duplicate work that could be removed here to optimize this, but I think I'm just going to go down this path first. I want to pass in our index. So we need a res. I think that's it for now. We'll figure it out afterwards. But let's just try to do our decision tree. So we want to take current index, or we want to not take current index. We need to keep track of what's already in our array. Triplet, let's call it triplet. And then we'll pass in an array here. In our take current index example, we want to take num sub I and append it to our triplet. Let's go triplet.append num sub I, and we want to check if the length of triplet is equal to 3. Then we want to take the sum. And then we don't even need a hash map, actually. Now I'm thinking about it. We just need a set. We forgot our base case, which I was thinking about earlier. If our I is greater than... If our I is greater than the length of nums, greater than or equal to, then I want to return. Boom. Run it. Your output was none. Am I printing res? That's right. Okay, so when I find like a pair, I still want to pop. I still want to pop from triplet. So, okay, so something is wrong here. So we get -1, 0, 1. That's correct. And then I want to pop 1 and pretend that I never took it. So now I'd have -1, 0, and I'd get to 2. Boom, pop 2. Go to the next index. So I'm not sure why this isn't working. An hour already. Oh my god, this was supposed to be so quick. Where is that coming from? Is it me you're looking for? I can see it in your eyes. I can see it in your smile. You're all I ever wanted. I love you. Okay. So instead of this being the else, I think it should just run each time. I see. We are just popping. We're popping and appending the same number. Okay. So I finally got it to where we are getting the correct output, but we are having duplicates. So in order to solve that, let's sort triplet. So triplet.sort. Okay, so after a while of deliberation, I finally got something that passes the run test cases. So what I'm doing is we're doing the decision tree, storing a set. Before I add something, I'm checking if it's in the set. already. In order to not have duplicates, I'm sorting them before I add them to the set. And to create the list from the set, I'm using list comprehension and grabbing the 3 items from the tuple. If a tree has not reached 3 yet, it's going to append the current index, and then it's going to go to the next index. Once it hits 3, it'll check, do the sorting. After that, though, so it turns out that this is not correct. I'm sure you can see why. I unfortunately cannot. Should I be returning in res.add? I don't think so. Okay. Wow. So that took a lot longer than I expected it to. I had some errors in my code. The first one being that this I was beating some race conditions when I had an answer in the last spot. So I had to move this if condition down. Returning in this res was also causing issues because sometimes when the sum wasn't 3, I was never returning, even though I should. I should always be returning so that I can pop. Nico doesn't have this type of decision tree solution in his. He does sorting. I think this is too quick before he shows that technique. But I am very happy with this. It is very long, and I'm sure it can be reduced. But I learned a ton from this, and just trying to come up with the logic was very interesting. But yeah, this is awesome. I'm glad I got accepted. That only took a very long time. Next time we have a container with most water and trapping with rainwater. Thanks for being here, checking out, listening to me ramble and be stuck on this for almost an hour, but it was definitely worth it, and I feel myself getting smarter. So I appreciate you guys watching, and see ya.